Now that we have a better understanding of what the correlation coefficient is, it's of course important for us to be able to calculate it ourselves. So the following table shows the percent of students who received free reduced lunch and the percent of students who passed the state math exam for several different public schools in Sandusky, Ohio. All right, so the first question it's asking is, what is the sample size? So each of these rows is a different school. So this school at the top had 29% of its students on free reduced lunch and 66% passed the state math exam, and so on. So when they're saying what's the sample size, they're saying how many schools did they go to and get this data from. And we can look and count, 1, 2, 3, 4, 5, 6, 7, 8, and so on, and find out how many rows there are. And the number of rows would be equal to the sample size, which in this case would be 13. And we could also get that number from StatCrunch when we go to find the correlation coefficient, but we'll see that in a minute. Oh, and this is misnumbered. I'll have to fix that numbering for later. Okay, so what is the explanatory variable? Well, the explanatory variable is also known as, just a little reminder, the independent variable, and it's x. So if we look, x is always for us in the left-hand column. So this would be the percent on free or reduced lunch. Oh, and if you're interested, these were schools. Right, they're not students, they're schools. All right, so this is the percent of student on free reduced lunch. The response variable is also known as the dependent variable, and that's your y. And it really pays to kind of label these for yourself so you can kind of keep track of what's happening, because there's two variables here, the x and the y. All right, so the response variable was the percent passing the math test. All right, now it's time for us to actually find that correlation coefficient. Okay, so how do we do that? Well, we do it the same way we do everything in Chapter 4, which was we're going to go to Stat, Regression, Simple Linear. It's that path for StatCrunch for this entire chapter. So that's your StatCrunch path for all of Chapter 4. All right, so let's go do that. Let me go get the data set, which right here in our list of data sets, we go to the free reduced lunch, that one. So if I click on StatCrunch and then click on the link, there it is. So we'll go Stat, Regression, Simple Linear. And then I click on Simple Linear. The x variable is the percent on the free reduced lunch. The y variable is passing the math test. And you can ignore all the rest of this. It doesn't matter to you. So you click Compute. Now it actually gives you a ton of information here, but these are actually later chapters. This is chapter 14 up here, and this is chapter 13, which we are not covering. So you can kind of highlight or isolate them. What you need is this top piece right here, because this has everything you need. And the correlation coefficient is right there. It says that R, and even labels it as correlation coefficient, which is very sweet, is negative 0.688. All right, now what kind of relationship is that? So we want to go back and grab the diagram for the R values and see what that would be. So negative 0.688, right, that's the correlation coefficient, is right here. It's between negative 0.5 and negative 0.8. So it's a moderate negative relationship. Okay, so when they say what type of relationship is there, it's a moderate negative relationship. And just a little reminder of what that looks like. A moderate negative relationship means that as your x goes up, so in this case, as the free reduced lunch goes up, so as the percent on free reduced lunch increases, the percent that are passing this math exam is decreasing. That's what a negative relationship means. It means that as x goes up, right, and the percent on free reduced lunch, that's your x, as it goes up and increases, then the y decreases. That was discussed actually back here, right? A negative relationship means as x increases, y decreases, also known as an inverse relation. So that's what we're seeing here. Now, why is this an observational study and not an experiment? Well, experiments actually require the researcher to randomly assign the treatment, to randomly assign the x value. That would mean that you'd have to randomly give kids free lunch and take it away randomly as well. And that would be unethical, right? You can't just go start taking away lunches from hungry children. That would be completely unethical and unfair. So I'm going to write that up. There we have it. So as I just stated, right, experiments require that random assignment, right, where you randomly give the treatment to some people and not to others. And that would be very unethical to do, involving children who are going hungry if they don't get lunch. All right, now because of this, because it's an observational study, we cannot argue that the free reduced lunch causes lower exam scores, right? That's not what's happening necessarily. All right, so we have an x variable, which is the free reduced lunch, and we have a y variable, right? X is going up, y is going down. That's definitely happening, but that doesn't mean that one is causing the other. That's because there could be other things going on that are affecting what's going on. You can kind of see it, right? This is a school with a high percentage of students on free reduced lunch and a low math exam passing rate, whereas this student at the end has a low percentage of students on free reduced lunch, so that has a high passing rate. But it's not because of that necessarily. And this is where the old phrase from many a science class can come to help us. It's a moderate negative correlation, but correlation is not causation because there are other things happening called lurking variables. All right, so you have to think about what a potential lurking variable would be. I just want to make that one word, such as, all right, and we'll come back for that blank. That's a blank. That would affect a school's free reduced lunch rate and passing rate. Right? The x and the y. And that's what a lurking variable is actually. So we might want to make a note of this because I don't think I have the definition written anywhere else. But a lurking variable is a variable that is impacting what's going on, but was not accounted for in the study. So it can be something else that's happening that is affecting your x and y, but was not considered in the design of the study or couldn't be considered because it's not an experiment, it's a study. That's the advantage that experiments have over studies, is that experiments can sometimes control for those lurking variables. Okay, so what's a potential lurking variable in this case? And if you're paying attention, you might have noticed I already wrote it. It's poverty, right? So poverty might be very much an impact on what's going on. You could also think of maybe infrastructure. Maybe the school doesn't have the resources. Maybe the parents don't have the resources, etc. But infrastructure would be more the school, right? Does it have clean water going to it? Does it work well? Does it have electricity regularly? That kind of thing. And then, of course, poverty of the students, poverty of the area, right? All of those things would be impacting, right? Now, notice the lurking variables in particular are trouble in a study, in an observational study. So all of this is happening because this is an observational study, not an experiment. Because you can't do an experiment because that would be unethical. But that means that you're open to having lurking variables impacting what is happening. One other side note I forgot to mention in StatCrunch that I want to make sure that I show you. You want to notice that the sample size is actually given to you right there. And it tells you right here what your variables are. Now you selected these, but the dependent variable is your response variable, so that's the y, and the independent variable, that's your x. So it actually has them right there listed. Dependent is response, independent is explanatory. It kind of puts them backwards a little bit. Sample size is right there, and correlation is right there. I just wanted to make sure everybody noticed that all of those items were there in StatCrunch for you.